Friends, we are from Walchand College of Engineering, Sangli Electronics Department. We selected project as a wireless data acquisition system based on Zigbee modules for remote sensing and monitoring using TI MSU 430. Our project participants are Lalit Rajput, Ravindra Pagare, Vishnu Bamble, Pranav Mali. As the system architecture of our project is as shown in figure, here we had a system which is closed or open. We here consider as a room, and we are controlling the system via using MSP 430 through MATLAB. Here we are using temperature sensor and light sensor. Temperature sensor LM35 and light sensor light depending resistance. And for controlling all the actions we are using a microcontroller as MSP 430, and for sending and receiving data we are using two Zigbees, one as a coordinator, one as a router. The flow of our project is as shown in figure. Initially, sensors measures the environmental value, then it passed to the microcontroller MSP430. Then microcontroller read it through this program, and it sends to the MATLAB. Then it MATLAB plot it on the graph. Then checking checking the respective value of the sensors and comparing it with the threshold value of the sensor. MATLAB is sending control action to the uh, through the router to the coordinator to control the action such as on the LED or off the LED. These are control action we have taken in our project. Guys, now I will explain you hardware part. This is a LDR sensor, light depending resistor, which we use to calculate the intensity of light in the room. This is the LM35 sensor, which calculates the temperature present in the room, and the two sensors continuously send analog data to the microcontroller MSP430. This MSP430 is comparing this value and converting this value in the digital through 10-bit EDC, and it transmitting through this router Zigbee to the coordinator Zigbee, which is connected to the another port. This is Energia software, which is compatible to the microcontroller MSP430. We use it to program or the microcontroller. Here we taken three variables B, S, and C to store the values of the analog values. Float temperature is store the temperature, and E3 is the analog pin where we are receiving temperature. Slash define LED1 green LED and slash define LED red LED. These two LED are we taken as output LED to show our control action. In void setup, we are setting this LED1 LED2 as in the mode output using function pin mode. Here serial.begin 9600 is setting the baud rate for the serial port as 9600, and digital write LED1 low and digital write LED2 are setting the LED1 and LED2 to 0 level. Now here actual program start void loop. Here temperature receiving analog data from temperature pin which is assigned to the A3, which is receiving the analog data from the sensor. Here we convert the temperature in the plotting form by using temperature is equal to temperature into 0.3515623, and where we are printing temperature and writing on the port, and here we go on the function, that is in conf function we are checking if data on the port available is greater than or equal to 0 or not. If data available is greater than 0, then we assign the value which is coming on the port to the yes, and if the value at the yes is exactly equal to 2, then we are writing at the LED2 as a high, then it glows, and we are taking delay of 1000. And again we are entering in the second function, that is in con1. Again we are checking value on the serial port. If the value on serial port is greater than 0, then we are checking it as to the variable s. If value is exactly matching with the 3, then again it high the LED1. It set the LED1 pin as a high. Again after completing this loop, it comes to to the delay. After taking this delay, it again come to the analog grid A4, where we giving the another sensor input, and where we are calculating the lux of LDR in the form of intensity, and again we are printing it on the through the port on the graph. To monitor, we are using MATLAB as an interface, and in MATLAB editor we are write this program where at s is equal to serial com11 comma baud rate 9600. Here we initialize the serial object s with properties like baud rate and com port, and here we have open the file name for the binary read access, that is the through the port. And here x is equal to 30, I is equal to 1, y is equal to 0 1 to x, and z is equal to 0 1 to x. It creates arrays of zeros from 1 to x, that is 1 to 30. When it enters in the while loop, that is I less than x until I is less than x. Here y of I is equal to f scan of s comma percent d. Here read the data and convert it according to the specified format string, and here the sensor data with the threshold value, and if value is greater than or less than, then after it taking action will write s to the string to the s, that is to the port. If value is greater than 10, then it write to the port as a 2, and after it receiving the energy and it takes action on the microcontroller. And here we take end of the if loop, and here we use function set gcf comma color comma sign. This function is directly this set gcf function is automatically calibrating the x and y axis and plotting the coming data which is on the port, directly plots on the graph, and this color sign is the background color of that graph. And this draws the coming value at the right moment. It plot instantly on the graph, and we use the two plots because we are using two sensors, LED and LDR. Therefore we are using subplot 1 for the LDR sensor to plot the light intensity in the form of lux, and the subplot 2 for the temperature in the degree Celsius. Here in subplot and in stem we plot the data in the form of stem. Here I comma y point arrow line width, that is we set the width of line which come in the form of stem as a 2. Then we give x label, y label, title, and hold on. This hold on value holds the previous value which come at the previous instant, and again it goes on increasing, that is value on the x-axis goes on increasing, but the values which are before those also hold by that function, that is hold on. Here the second function zi is receiving the value of the temperature, and it taking from the port, and if again it controlling it with 1110. If this value is greater than or equal, again it write to the port and again takes control action through the Energia. And we are plotting here another graph using subplot, stem, x label, title, and hold on. Hold on works same as explained in above case. Here I is equal to I plus 1, that is I increasing its value, that x-axis is increasing, and here is the end of the whole loop. And here we close the port and delete the port to take the next action. Here we run the program which is Energia. After running, it compiles and upload in the microcontroller, and when we see the erasing program and done, that means your program is successfully loaded. Here is a serial window through which we can see the value which are given by our sensors, that is LED and LDR. Here is the values of given by the LED and LDR. This is value of the LDR, that is 547, and this is value of 13.80. These values are given by alternately given by the LDR. Sorry, these values are alternately given by the LED and LDR. MATLAB program from this run button, and it gives us value of LED and LDR and LM35, and it plot on the two graphs using subplot. Here on the y-axis of the two graphs, First is the LDR graph, second is the temperature sensor graph. On y-axis we are taking light in lux, and in second graph on y-axis we are taking temperature in degrees Celsius. The x-axis graph for the both graph is same, that is time in second. Here when light intensity is less, then it given value in the lux, which is also less, and when light intensity is more, the value given in the lux is more, because these values depend on the LDR. If LDR is a positive coefficient, that is, if LDR is a positive coefficient, then if the light intensity increases, then value also increases, and if light intensity decreases, then value of LDR also decreases. If we use this negative coefficient, then if the light intensity of light is maximum, then value given by the LDR is minimum, and if the light intensity of LDR is minimum, then value given by the LDR is maximum, due to which we use here a positive coefficient. Therefore it giving value as at this is at max intensity, and this is at less intensity. The second graph is of the temperature, which is lies between the 0 to 30, and average range is between the 25 to 30. And here we are taking the control action by glowing the LED. We are using this LED for the LDR. If value goes above the 6000 lux, then LDR glows 1000. So here it shows control action, that is, if light intensity is more, then it glows the LED. And right now temperature is less, due to which it doesn't show us a control action. Here we plot the graph, which is runtime. Using GCF function, it calibrate the x-axis and y-axis automatically, due to which it shift upward and downward graph automatically. Here values are going runtime. This is a runtime graph, which you see it plots value up to the 40. So this is our whole project, and we perform it using ZigBee microcontroller and using MATLAB.